Hey warriors, this is how to calculate the eccentricity of an ellipse. So you'll be given an ellipse, something like this, and if we're working online, you will be given these measurements, but I'm just gonna measure these real quick in case you are not doing this online. So the first distance that we have is this one between the two foci, so F1 and F2. And in astronomy, one of these will be your star or your sun, or a planet if we're talking about like a satellite or something like that. And so the distance between the foci, which is used to draw that ellipse on this particular one, is 7.5 centimeters. And we're gonna try to be as accurate as possible. So, but that's not really the distance I need. I can use that if I want, but I really need this halfway point to one of the foci. So because this is the triangle that's already in there, I'm gonna go ahead and measure from there. So I'll measure from there to there. And I get about 3.7 centimeters is what I came up with for that measurement. And you can agree or disagree with me based on what you see there in the view there. And then I'm gonna measure this one and I'm gonna see what I get there. And so now I'm sitting at about, what do we think? 7.9, right at 8. I'm gonna go with 7.9 centimeters. I wrote that right on the line. It's kind of hard to see. 7.9 centimeters. There we go. And so now I have my two different, my two measurements that I need. So I could have gotten 3.7 by dividing that one out. So that's why I actually took that measurement, if you want to do it that way. So then I need to know what the equation is. We will always give you the equation E equals C over A. Well, Miss Bergman, which one's C and which one's A? You've got two options. You can memorize this one, the base of the triangle is always C and the hypotenuse is always A. I've asked the math teachers, no one can tell me why this is different than what it is when you go to do a right triangle in math class. No one, I have not yet to figure it out. If you figure it out, you make sure you let me know. So that gets confusing, right? So what you do need to know is eccentricity of ellipse will always be a number between 0, which is the eccentricity of a perfect circle, or 1, which is if I stretch these all the way out, I would end up drawing a straight line. So the eccentricity number is very closely linked to the shape of the circle, or the shape of the ellipse. So if it's 0, it's a circle, and if it's 1, it's a straight line. So here we've got something that's sort of squishy. I can kind of sort of see that it's an oval. So my guess is it's going to be a lower number. It's going to be closer to 0 than it will be to 1. So in order to get that number to be greater than 0 and less than 1, I have to divide the smaller number by the bigger number. Easy way for me to remember that. So I'm going to take 3.7 and I'm going to divide that by 7.9. So when I plug that into my handy dandy calculator, can you see my handy dandy calculator? 3.7 divided by 7.9, I get the number 0.468. So if I'm putting that into an online version, you would probably round that to 0.47. And so that's going to be my final answer. So that's how you calculate the eccentricity of an ellipse.